to the workshop, and welcome to this new segment which I'm going to call Saturday Night Review in the Workshop, where I'm going to answer some of the questions from patrons and subscribers to my channel. And the big one for this week is, well, accuracy of CNC machines, and I will try and explain to you in a mixture of imperial and metric, if I don't get myself confused. So I'm going to walk around with the camera a little bit and do a little bit of explanation. Okay, so this is going to be a bit of a mixture of machines between lasers, CNC routers, and CNC milling machines, and a mixture of lasers too. So, accuracy. Now then, this first machine, laser, as you all know, is my Thunder laser, which is a Nova 35, and it's 100 watts. Beautiful machine. It is probably the best, should we say, home industrial machine that you can buy. For reasonable cost. And if you're going to go into business at home, or in a factory for that matter, these are the machines to get. Having said that, the accuracy of this machine is pretty damn good. And what I can tell you, and I've had quite a few lasers, the accuracy with this is approximately 0.1 of a millimeter, which is about 0.004 of an inch. Now I'm going to say approximately conversion. All right, it's sort of difficult for me to sort of work it out in my head. It's between 3.5 and 0.004 of an inch. And basically the reason for that is this drive belt down here. Now this is made up of like a silicon rubber, and inside of that is carbon fiber filaments, or there's also carbon fiber in that belt to stop it stretching. Well, when this goes from one side to the other and back and forth very quickly in all axes, obviously the belt stretches and retracts each time, and it doesn't quite go back to the same position. And we're talking sort of microns here, okay, but they sort of all add up. Plus temperature and humidity has a lot to do with it, as well as also drag on the rail here. So about 0.004 of an inch is pretty damn good for a laser. And also, the focus of the beam is a lot to do with that. To get a nice crisp edge or cutting edge. If you've got, if you're out of focus just a little bit, or even if your mirrors are dirty just a little bit, you're going to get a different result, and it's going to show up in the accuracy. But 0.004 of an inch is very good for a laser of this type. Okay, moving on to a fiber laser, which is over here. Now this is a 30 watt fiber laser, and you can get down to an accuracy with this to approximately 0.05 of a millimeter, which is approximately 0.002 of an inch. The beam on this is much finer, and therefore you can get more accuracy with it. And that for a fiber laser is extremely accurate. And this rather grubby looking laser, I haven't cleaned it actually. I haven't actually used this for 12 months. This is a K40. A K40, you may get an accuracy of about 1/8 thou, which is 0.2. Okay, so that is basically lasers. So, you know, they're fairly accurate, and, you know, sort of they're built for, you know, repetition, fast cutting, knocking out work. Basically knocking out work. Sorry if you're getting a bit of glare from the lights here. Okay, CNC routers, which, you know, I know practically about 60% of you are interested in the CNC routers and, you know, the mill and the lathe. Okay, it's a bit of a minefield. Now, okay, the Genmitsu over here, the 6050. I haven't done really any work with it yet, but what I'm sort of gathering with it is I think it can hold something like 0.2 of a millimeter. It will, you know, it will machine fairly consistent, you know, sort of with that figure, which is 1/8 thou. Now the reason for that is, you know, the type of bed that it has and generally the type of screws that it has, but that is pretty accurate for a small CNC router. What you've got to consider is humidity. You know, you've got not a wood, but it's a man-made wood bed and aluminium, and, you know, temperature and also humidity is going to affect that. It's going to, you know, expand and contract, as it will all the materials in the, you know, the gantry and all that. You know, it's going to move. You know, you can try and keep it at a constant temperature and a constant humidity, but that's the only way you're going to keep it at a constant value then, you know, of accuracy. But for everyday use in your home workshop, you know, you're going to be lucky to keep it at 0.2 of a millimeter, which is 1/8 thou. You might think to yourself, oh, blimey, that's not very accurate. Well, you know, the nearest 1/2 millimeter actually, when you're doing woodwork, it is actually fine. Okay, moving on. So that, you know, this is a good machine, and for a small CNC router, that is a good accuracy. And I know there's probably going to be some naysayers out there going, oh, my machine's a lot more accurate than that. Well, I'm afraid to tell you that it's not. Okay. Now this one I'm getting a lot of, you know, sort of a lot of interest about, which I'm going to get back onto over the next few weeks. It's just, you know, tell you the truth, we've had a lot of bad weather here in Tasmania, and yeah, I just haven't been able to get up here and film, and I've been putting videos up that I have already filmed and has, you know, has been in the can, and I've been able to sort of put that out. But you know, I actually put the Genmitsu out about a month prior to what I was really going to. I was going to get this one up and running. This is, you know, is the QueenAnt, and from the last video it hasn't been touched, which is about 5 weeks, 6 weeks, 6 weeks maybe. But I will be getting back into this hopefully the end of this coming week, and I shall be, you know, I'm already actually getting started, you know, with the electrical pack here, and starting to, I'm going to be filming, I think Monday or Tuesday, starting the wiring up of this. Okay, but we're talking about accuracy at the moment. Now, this is going to be this pretty well the same as the 6050 Genmitsu. You know, 8 thou is about the best you're going to get, which is, you know, 0.2 of a millimeter. Because it is made up of many parts, and again with expansion and contraction, and it's going to have an MDF bed as well, and humidity, that is about the best you can expect. And it's really plenty good enough, you know. Sort of a lot of you out there, like I said just now, are going to say, oh, but my machine's, you know, sort of, oh, I can get it within a thousandth of an inch. Well, I'm sorry, I'm here to tell you that it's not. It really isn't. You may, as you're doing a test cut, at that moment, it may get you within 2 thou, possibly. Half an hour later, it's going to be out, because the humidity is going to be different, or the temperature is going to be different, and things expand and contract, and especially something like this, that with many parts, you know, all the parts move in different directions at different times, at different temperatures and humidity, and it's going to go out again. So it's very, very difficult unless you keep your router in a constant humidity and temperature. You can't do it. That's the truth. Okay, moving on. Even the one that I designed and built, okay, exactly the same. You know, really and truly 0.2 of a millimeter is the best you're going to get, okay? And this one's more solidly built. You know, it's got a, you know, 3/4 inch thick solid aluminium gantry. Okay, now I did that to stop the gantry from flexing. So, yeah, that's another thing too. As the machine is cutting, you know, you're going to get a certain amount of flex. Well, I built this, you know, good solid, you know, sort of 1/2 inch uppers, 3/4 inch gantry main back plate. It's still going to flex, but not as much as others. Okay, so I think we've established now that temperature, humidity, and flex with the machine cutting, that is basically the sort of accuracy you're going to get, and it is going to change as the machine is running. Let's get that shadow out my face. There we go. And it's going to change as the machine is running, and you know, with temperature and humidity. Okay, you can get that a little better if you have something like a CNC milling machine. Just get this open. Now, the reason that you can get more accuracy out of something like this is because it is solid cast iron. Cast iron is more stable in temperature and humidity than what, you know, anything sort of aluminium, you know, this, although this is a solid structure, okay, it will move with temperature. The sort of temperature that exists in a workshop, you know, sort of, should we say, minus 5 or 6 degrees C to sort of plus 40, this isn't going to move at all. And not only that, it stays rigid. Okay, when it's cutting, it stays rigid. So this particular machine, you can, if you are very gentle with the finishing cut, get this to cut within 1 to 2 thousandths of an inch. That is the best you're going to hope for, which is 0.03, which is approximately 1/1000th of an inch, to 0.05, which is 2/1000ths of an inch. 1/2 thousandth of an inch, very, very difficult. So if you take a job to an engineering shop and you say to them, oh, I want plus or minus 1/2 thousandth of an inch, and they say, oh yeah, we can do that, no problem. I'm here to tell you that it is extremely difficult to get something with a tolerance of 1/2 thousandth of an inch. You know, sort of, or 1/1000th of an inch, doable, that's okay. 1/2 thou? Questionable. So I can hear you say, well, oh, okay, what machine is capable of mass production or producing something of, of 1/1000th of an inch? Okay? Because mass production of anything within 1/1000th of an inch, metal things, you won't get it with wood. You can't even measure 1/1000th of an inch, which is 0.03 of a millimeter. You can't even measure that on wood because the fibers won't allow you to do it. So I can hear you say, well, what machine can you get to machine down to 1/1000th of an inch? Well, in the background, I don't know whether you've noticed, there's been a video playing. Okay. Now this is a form of CNC Router. It's a German machine, and it is called a Patron. It is the only machine I know of practically in the world that is built like a CNC router that will absolutely machine to 1/1000th of an inch every time, providing you keep the tools brand new, because even tool wear will alter the outcome of the accuracy of the machine. But that's a Patron, and I think you've heard me say to you in the past, you get what you pay for. Well, that particular machine that you can see running there is a Patron Nano. It's the smallest machine they make. Its cost is in excess of $50,000 US. And believe you me, it is worth every cent. Those machines are built with German precision, linear square rails and ball screws and stepper motors. There's no Chinese stuff in that. And, people like NASA or BMW or Mercedes, they run machines like that, and, obviously others too. This is used primarily for rapid prototyping. In actual fact, they're prototyping a part on there now. That is a machine that you can reliably machine to 1/1000th of an inch. So I think you may understand now a little bit of, CNC routers and CNC milling machines and lasers, and maybe understand that, oh, well, perhaps that the accuracy of them aren't bad. When you get down to sort of 0.008 of an inch, it's okay. It really is okay when you're dealing with wood, because there's so many variables with the temperature, humidity, cutting flex, gantry flex, and all that sort of thing. There's a lot, behind getting the accuracy of a machine. Okay, so I hope that's given you a little bit better understanding now of accuracies and why you can't get a CNC router sort of to machine plus or minus sort of 0.005 of an inch. It's damn well impossible unless you've got a Patron. And anybody that tells you, oh, he's talking rubbish, of course you can, my machine's very accurate, well, I don't think they really know what they're talking about. Any manufacturer that tells you that this CNC router can machine to 1/1000th of an inch or 0.03 of a millimeter, well, they're not strictly telling you the truth then, are they? Because there are a lot of variables. So, okay then, coming up between now and Christmas, I'm going to be doing quite a bit with Carveco and these two new machines, obviously finishing the QueenAnt off, get that up and running, and do some cuts on the Genmitsu 6050 and the QueenAnt, as well as I will be doing going back to doing some more laser work as well. So I'm going to be pretty busy between now and Christmas. So thank you for being there, guys, and for those of you who are enjoying my videos, I'd like you to consider becoming patrons to the channel, because it really is the patrons behind the channel that keeps me going, making these videos, because I think you may have noticed quite a few of the guys, sort of I suppose it's been on YouTube for let me see, 12-15 years. They're all dropping out and disappearing, and the reason being is there's just no revenue left on YouTube. Since the Carpa thing came in, it's just gone absolutely dead. You get the views, but there's no money. So I just don't know what the answer is. I don't know what Google and YouTube are going to do, but everybody's just dropping out, and I'm just sort of hanging in there because I have patrons that sort of allow me to keep going, but for me to keep going, I do need more patrons. So if you can, I would be grateful. I do understand that down below the video now, I think you can leave a tip, you know, like I think they call it a cup of coffee or something. You can do that way as well if you want to help the channel out. But you know, if you can't, just, you know, press like and subscribe to the channel, because, you know, that helps with the algorithms as well. So until the next video, and it's probably going to be the QueenAnt electrical. I might actually slip another Genmitsu machine in as well before the end of this weekend. And most definitely there'll be a Carveco. Incidentally, below this video, as always, there is a discount code there for any of the Carveco programs, which, you know, is the best on the market. So until the next video, thank you guys for being there. Thank you patrons, thank you subscribers, and I'll keep going. So it's bye for now.